Welcome to the runtime error, the place where programming begins. In this video, we will be discussing the question called as a shortest and lexicographically smallest beautiful string. So we will solve this question in two different steps. So I highly recommend you to watch the video till end so that you can come across every single detailed solution of this problem. So let's discuss what does the problem says that. So we have given a binary string. So what do you mean by binary string? The string which contains only 0 and 1, which means apart from 0 and 1, there is no any other character present in my string. Along with the binary string, they have also given an integer called as a k. So what we need to do is we need to find a substring yes such that in that substring my total number of 1 is always equal to exactly k, right? Say for example my value of k is 3, then this means that in my string there should have exactly 3 number of ones. So this is called as a beautiful string because I have exactly 3 number of ones. But if I say 0 1 1 0 1 1, this is not a beautiful string because the total number of ones are 5 and the 5 is not equal to 3. So I hope so you understood the meaning of beautiful string. Now what does the question say that we need to return lexicographically smallest beautiful substring. So what do you mean by lexicographically smallest substring? Say for example we got a string called as a b c d and another string as a b c c. Now if you try to compare each and every single character one by one, a is equal to a, b is equal to b, c is equal to c, but d is not equal to c. But if you try to compare it with alphabetically, C always comes before D, right? This is the reason why this is treated as the smallest lexicographically string. So I hope so you understood the meaning of the question and the meaning of lexicographically smallest string. Now let's try to analyze the sample input output so that we can derive the solution for this. The small input they have given to us, that is the 1 0 0 0 1 1 0 0 1, and the value of k is equal to 3. So what we need to find is we need to find the substring which is smallest and contains exactly 3 number of k, 3 number of ones, right? So we have a total of 7 substring, right? Out of the 7 substring, which is the smallest one they have mentioned. So if we can see is 1 1 0 0 1. So this is the smallest substring lexicographically, and I hope so you understood the meaning of lexicographically as I discussed over here. So these are the example input output they have given in the question. Now this is the substring. Say for example I got 1 0 1 1 and my value of k is equal to 2, which means I need to find the substring which have exactly 2 number of ones. So I got 1 0 1, I got 0 1 1, I also got 1 1. Now if I try to compare which one is the smallest one, right? This is the smallest one, so I return 1 1 as my substring, that is beautiful substring. So I hope so you understood the sample input output question. Now let's try to derive the solution for this problem. Okay, so before deriving the solution, I have to take this example so that we can understand the intuition behind this problem. So one thing is sure shot that I need at least or exactly 3 number of ones in my substring, right? So I got 1 2 3 4. There are total 4 number of ones, but I should have exactly 3 number of ones in my substring. And what do you mean by substring? The substring should have the continuity. I cannot say 0 0 1 1, this is my substring. No, because we don't have any continuity in between them. It should be a continuous string. And most interesting, I need exactly k number of ones in it. So what we will do is we'll simply keep one counter, say for example cnt, which is initially initialized to 0. So what does this counter say? That it will count a number of ones in my substring. So initially my cnt is equal to 0. So what I will do is I will start traversing a string. So I will come here 1. Now again I will going to take a temporary string called as a temp, because what I need to do is I need to find the substring, and that should be a lexicographically smallest one. Now I come across 1, and how many 1 I encounter? 1. So I simply increase the 1. So I also inserted 1 in my string. Now I come across 0. Is it equals to 1? No. Therefore my counter will not get increased, but I will add that 0 in my substring. Again I will come to add this 0. Is it equal to 1? No. Therefore I will not increment my counter and I will add that 0 in my substring. Then again I come at over here. Again it is not equal to 1. Therefore my again counter remains the same, and I will simply input in my temporary substring. Now I come across 1. Now it is equal to 1. So I will simply increase the value of counter plus 1, and I will add that 1 in my temporary string. Again I come over here. Again it is equal to 1. Again I will increase the counter by 1 and add my 1 in my substring. Now I can say that my value of counter is equal to k, which means I found a substring which has exactly k number of ones in it. So what I will do is I will simply keep this substring in my vector, because what I need to do is we need to return lexicographically lexicographically smallest. So we don't know which one is the smallest because just we found the first substring. There might be another substring that which is smaller than this and which has exactly k number of ones in it. So what I will do is I will simply keep this substring in my another data structure called as a vector. So say for example this is the vector and I'm storing at 1 0 0 0 1 1. So this is my first substring. Now what is the size of it? What is the size of it? If I try to get the size of this 1 2 3 4 5 6, so total size is 6, right? Now what I will do is now again I'm going to start checking the substring from this position. From this position I will start, because earlier before this I started with this one. Now I'm starting with my second character. Now again my temporary string will be empty and this count will be equal to 0. Now again I will check, is it equal to 1? No. So I will simply put this inside my temporary substring. Now again I come across G0, is it equal to 1? No, but I will put this in my temporary string substring. This is not equal to 1, so I will put in my substring. Now this is equal to 1, so I will increase my counter by 1 and will put that 1 in my temporary substring. Again I come across 1, so I'll simply increment my counter by 1 and put that character in my temporary substring. It comes 0, so I will add 0. Again I come at 0, again I will add 0. Now I cross 1, so my counter becomes 3 and I will add it. Now I can see that my value of counter is equal to k, which means my substring has exactly 3 number of ones in it. So what we will do is we will add this substring in my temporary vector, that is 0 0 0 1 1 0 0 1. Now before this my size was 6. Now I will check, is the size of this temporary substring smaller than 6? Let's check 1 2 3 4 5 6 7 8. No, it is not smaller than 6. Therefore I will not update my size, right? Because until unless I don't get the smallest size, I will not update it, because at the end what we need is we need a smallest lexicographically beautiful substring, right? And we are here we are getting the largest one, so we don't want largest, we want smallest. So far we got two substring, and out of these two, smallest size was 6, right? So I will not update the size because this one is greater than 6. So I will move ahead. So what I will do is again my temporary string become 0, again my count become 0. Now I will start from this 0. It is 0, so I will add it in 0. Again I come across this 0 0, then I come across 1, so my incremented value by 1 and inserted 1. Again I come across this one, it get 2 added here. I get 0, again I come across over here 0, and then I come across over here, incremented by 1 and added here. Again we can see that the value of counter is equal to k, which means I got one more substring which contains exactly k number of ones in it. Now again what I will do is I will put this substring over here. So what is the substring? 0 0 1 1 0 0 1. Now we'll check, is the size of this substring smaller than 6? We will check 1 2 3 4 5 6 7. No, therefore I will not update the size, because I got 3 substring, out of which this one is the minimum size, which is of size 6, right? And we want the smallest. So again I will start from next position, that is from this, right? Now we'll check, is it equal to 1? Yes. So from 0 it becomes 1 and added 1 to my temporary substring. Again I come across over here, then it's got 2 and it's got 1, then 0, again I come across this at 0, then I come across this one but 3 and added over here. Now I can see that my value of counter is equal to k, and which means I got a substring which has exactly k number of ones in it. Now what I will do is I will simply put this string in my vector 1 1 0 0 1. Now we'll check, is the size of this less than 6? I will check 1 2 3 4 5. Yes. Therefore what I will do is I'll simply update it to 5, because it is the minimum so far. So far we got 4 number of substring, out of which this one is the minimum one, right? There might be a possibility that we get another substrings, but this is the smallest substring we are getting. So finally what we'll do is we'll sort we'll sort these strings and we will return the substring whose size is 5. So I come across here, this size is 6, then I come across over whose size is 8, then I come across over here whose size is 7, then I come across over whose size is 5, which means this size is matching to this, and I will simply return this substring. So I hope so you understood the intuition behind solving this question. Now let's try to design the algorithm for this. Say for example this is the function which has s called as string and k is my number of ones in it. So what I will do is I'll simply define the vector in it. In Java you can define a list, say for example arr, and again I kept it as a size which is initialized to int max, because what we need is we need a smallest one, right? Again I initialize the count equal to 0, because we need to count how many number of ones we encounter. So simply what I will do is I will simply start our thing, that is from 0, to n, that is n is nothing but my size of my string, and again I am traversing. So what I will do is, again I will start from j equals to I, j is less than n, and j plus plus. Then I will check if my s of j is equal to 1, then what we need to do is we need to increment the counter by 1, right? Again we need to check if my counter is less than equal to k, we need to add it in my temporary string. Now say for example this is my temporary string and this is what I added, s of j. And again I will check if this is a main condition, if my counter is equal to k, what does it mean is, this means I got exactly k number of ones, right? This says that I got exactly k number of ones. So what I will do is I will simply put that ari.push, I need to put that temporary. Again what I need to do is I need to calculate the minimum size. So what I will do is size is equal to minimum of size comma, that is temp dot size, which means the size of the string which we are getting from this. So we have initialized int max, and this is the size of the temporary string that we are generating. And again what we need to do is, again we need to initialize the count to 0, because we need to make sure again we are starting with new substring, because I already got a substring whose number of ones in it is already equal to k. Again, so finally what we will do is, once we get over here, what we will do is we will simply sort the vector, which contains the string in it. And finally what we will do is, again we will start from 0 to n, that is we will be traversing the vector, and we will check if my size is equal to array of I dot size, which means what does it mean is, over here this is my array, right? If I come over here, what will be size? 1 2 3 4 5 6. Now is it size 6 is equal to this size? No. Again I come here, what is size? 1 2 3 4 5 6 7 8. Is it 8 equal to this 5? No. Again this comes 7 is equal to this 5? No. Then I come across this, is it 5 equal to 5? Yes. Then I will simply return this substring. So this is what I did. If my size is equal to array of I dot size, simply what I need to do is return arr of I. And if in case if this whole condition get false, which means I don't got any of the string whose size is equal to size, then simply what I need to return is I need to return empty substring. So I hope so you understood this algorithm. It's simple. We simply store all possible substring in vector, then we keep the variable called as counter, just to make sure we got exactly k number of ones in my substring. Once I get the exactly k number of substring, I inserted that string in my vector and I calculated the size of that substring, because what we need is we need the minimum size. It is already mentioned in the question. And again I initialize my counter to 0, because I need to go for the next substring. That's the reason why I put the cnt is equal to 0, right? And what I did, finally I sorted the vector which contains all the substring in it, and again I checked if this is my minimum size equal to any of the size of the string present in my vector, I need to simply return that vector. And finally if I don't get any of this, what I need to do is I need to return empty substring. So I hope so you understood the intuition as well as the algorithm for this question. Now let's try to see a C++ and Java code for this problem. So this is a CPP code and this is a Java code for this problem what we discussed above. So what I did, so this is simply I declared the n, which is the size of my string given here. The same thing I did over here. Then I took the counter, that is we need to count the number of ones present in my substring. And the same thing I did over here. Now I declare the temp, that is max value. So why do we need a temp? So say temp is nothing but the size we need to check. That is what we need is a minimum size. So for that purpose I initialize to maximum, because what we need a minimum, that's why I declared it to maximum. Then I declared the string as an answer, and this is the vector as we discussed over here, right? What we need to do is we need to store all the string in my vector. So that's the reason why I declared the vector in C++. In Java we came across the array list. Then we traverse by string by generating all possible substring. So again I checked if it is equal to 1, I increment my counter, because we need exactly k number of ones in my substring, and that's the reason why we need to keep a counter to make sure in our substring we got exactly k number of ones. Then I checked if my counter is less than equal to k, I need to put that character in my temporary string, that is s2, right? And once my counter is equal to k, so what does it mean? We got exactly k number of ones. So once we get that, we put that substring in my temporary vector, that is arri. Then I calculated the size of it. What we need a temp. What does it say is that we need a minimum size of string. minimum size of substring. Here see 6, 8, 7, 5. This is a minimum one. So that's the reason why I'm keeping an extra variable to make sure I get the minimum size of any of the substring. And again I'm initializing the counter to 0 because we are moving to next substring. The same thing did over here in Java as well. And finally what we did is we sorted the vector in which we have stored all the possible substring in it. The same thing we did in Java as well. And then I checked if my temp, what is temp? The minimum size of a substring we came so far, right? That's what the temp says that. What does temp says that? Minimum size. Temp is nothing but the minimum size. And I checked is my vector contains any of the string whose size is equal to minimum size. If it is, I simply initialize to my answer and I break, which means that is my answer, because as we discussed over here, this is a substring which has the minimum size and which is equal to this 5, because so far that is 6, 8, 7 and 5. 5 is the smallest and this is a substring whose size is 5. So I need to return 11001. I don't need to check any further of it because this is the smallest substring we came across. And simply we come across break and return the answer. Even if in case this condition gets false, anyhow we are going to return an empty substring because here answer is not initialized to any of the character or any of the string to it. So I hope so you understood the meaning of this question and solution for these problems. Just in case if you are new to our channel, I highly recommend you to subscribe the channel so that you can come across a daily solution to Leetcode problem. Till then, have a happy coding.